warahmatullahi wabarakatuh. How are you all students? I hope you all are fine and welcome to the lecture number 2 of computer. So let's get started. Okay, so today what we are going to discuss is related to history. So anybody know what is history? Yes, you must be thinking a lot of things. So history is something we denote with the study of past events. Okay, so we were discussing when we have started chapter number 1, that is introduction to computers, and we have discussed definition, characteristics and limitations of computer in the lecture number 1. Now today we are going to study about history of computer. So let's get started. History of computer. First device which we are going to discuss is abacus. So what is abacus? It is a device which was invented around 5000 years ago in Asia Minor, and it is still used today, and it is known as the first computer. It has a system of beads arranged in a rack, and merchants used for tracking transactions, and it also lost its importance because the use of paper and pencil was spread in Europe. So the next machine after abacus came into being after 12 centuries. Here is a little video for your understanding that how the decision for any calculations performed.
The abacus is an ancient calculating tool and is constructed in the power of tens. So that means that here we have the units, then we have the tens, the hundreds, thousands, 10,000, 100,000, 1 million, 10 million, 100 million, and the billion. So that means this tool goes from 1 to 10 billion. So the simplest thing or the simplest kind of calculation you can do is if you stay here on the units place, like 4 plus 3, 4 plus 3 is 7.
The next calculating device is Napier bones. In 1612, John Napier made the first printed use of the decimal point after it had been invented in the Netherlands, and invented logarithms and several machines for multiplications. What are logarithms? These are simply means the calculation which we done through some procedure. So logarithms are, in simple terms, the method which we use to draw some calculation. So best known for his machine was the bones or Napier's bones, and this device consisted of a set of 11 bones or rods with numbers marked on them. So by placing these rods side by side, products and quotients of large numbers can be obtained very easily. What are products and quotients? When two numbers are multiplied, so we get the product, and when we divide the two numbers, we get the quotient. So as you can see in the figure, you can see if I multiply the rod 1, that is the first column, and the above row, first row, if you multiply 1 multiplied by 0, so the first box is 0 0. 1 into 1, 0 1. Obviously 1 into 1 is 1. So consider the lower part is the units place or ones place, and the upper part is the tens place. So these are the multiples, and when we place these rods side by side, we get the product, or if you want to divide, we can easily get the. Here is a short video for you to understand what is Napier's rules and how do they calculate numbers, or how do we multiply using Napier bones.
In this video I'm going to show you how to multiply using Napier's bones. You'll love this, it's so easy. I'm not going to use square roots today, so I'll leave the square roots bone to the side. I'm going to multiply 6,473 by 8. Now we'll take the bones out. We need a 6, and then a 4, a 7 and 3. So we need a 4, a 7 and a 3. And all we need to do now is take our answer grid, and we're multiplying by 8. So we put it on at 8. And then we move down the diagonals and we get our answer. So there's only 1 in the first bit there. So you get 4 there, 2 plus 6 gives you 8, 5 plus 2 gives you 7, 8 and 3 gives you 11, so that's 1, carry 1 and we get 5, so we get 51,784. Now I'd like to show you it a bit bigger so you can see exactly where it's coming. I've used different colours so it's easier to see. The 4 there gives you 4. Then the next diagonal, 2 and 6 is 8, 5 and 2 is 7, 3 and 8 is 11, 1, and we carry the 10, so 1 plus 4 is 5, and our final answer, 51,784.
Next, the calculating device is slide rule, and as you can see in the figure, slide rule was invented in 1622 in 17th century by an English mathematician William Oughtred, and slide rule is in a circular shape, and it was also based on Napier's algorithms, and some of the calculations by 19th and 20th century engineers are also done. And it has two movable rulers which are placed side by side. You can see the two movable rulers, and each ruler is marked in such a way that the actual distances of the ruler are proportional to the algorithms of the numbers on the ruler. Yeah, and it was helpful in multiplying and dividing numbers, and it gives up accuracy up to 3 digits. Accuracy means the perfect result, how much it gives us the perfect result perfectly. And it is an analog device. How many of you seen the digital clock and the analog clock? Digital clock means the clock which gives us the numbers in the time in the number forms, and the second one is the needle one. So the accurate result is actually attained in digital one. So it is not giving us the results perfectly. The results are going to be arbitrary because we are going to get the results on the circular scales. So it is not suitable for accounting because in accounting we have some calculations, like for example the calculations are done for banking sector, so it is not going to be a suitable approach for them. So why we are studying history? Because we can predict some new inventions, and we can use our past experiences to have a research on new projects. Here is a video, and as students we are having these videos just to motivate you, so that because some of the students have the question in their mind why we are studying this, and they really want to know how they are going to calculate or how they used to do the calculation in that era. So I have inserted these videos for you. Okay, let us see.
To do multiplication and division on a slide rule? It's simple. First, let's introduce the scales that we're going to use. We're going to use the C scale and the D scale. These are the most basic scales on the slide rule. The left side 1 on the C and D scales we're going to call the left side index, and the right side 1 or 10 in this case you can call the right side index. When multiplying, you take one of the indices of the C scale and set it to the first number you want to multiply on the D scale. So say for example we want to multiply 7 by 6. So we take one of the indices on the top and move it to the number you want on the bottom. So if I try the left side, then okay, so I've moved it here, okay? Or well, multiplying by 7 by 6, right? So let's move it to the 7. Right? And I move the cursor here to verify that it's actually in line. Okay, they're in line. But now the second step is to move the cursor to the 6 on the top scale and then read the answer on the bottom scale. Since 6 is all the way over here, off the slide rule itself, we'll need to use the right side index. So let's move this and put the right side index upon the 7. So line it up. It's close enough. Okay, now we move the cursor to the 6 on the top scale and read the answer 4 and then subdivision 1 and 2, 42 on the bottom scale.
Okay, now it's an activity time. You have to multiply the total number of participants with the current month using Napier's-Bones calculation method. Okay, number of participants means the students which we are having of class 8, A and B in our class. For example, we have 60 students. So I am giving you the example with number 42, and 7 is the current month, that is the 7th month of July. So how to do calculation using Napier's modes? Just see, just focus. How many of you remember the table of 7? 7 1 times is 7, 7 2 times is 14, 7 3 times is 21, 7 4 times is 28, 7 5 times 35, and up to 9. So the very last digit is the unit, and the very next digit after the last digit is the tens, just like we have in mathematics, the ones and the tens. So the lower part of that rectangular box is of the square is the unit, and the upper one is the tens. Okay, do you get it? So I have just took out the two numbers, that is 42. So 7 4 times is 28 and 7 2 times is 14. Is that clear? So now we are going to calculate how much the calculation we have done correctly. We have to write the leftmost number as it is, that is 4. Sorry, the rightmost number 4 as it is. Then we are going to add the upper number, that is 1, with 8. We are going to add them, we get 9. Then the remaining is 2, so 2 will be copied as it is. Okay, this is just an example. You have to practice. You can do that practice with any kind of number without calculator. Okay, so here is a question for you today, that you have to define a biggest Napier's bone slide rule in detail. I have already provided you the PDF, or I hope you all have bought some, or you all have bought that computer book, so you can ask some questions in your class. Okay.